Hello students. Welcome to today's chemistry lesson. We'll be studying gas laws part 3. But first, let's quickly review what we covered in our previous class. In our previous class, we studied the general gas equation, which helps us understand the relationship between pressure, volume, and temperature of a gas when none of these factors is constant. This relationship explains why gases can behave dangerously under certain conditions. For example, in an aerosol spray can, an increase in temperature can lead to a rise in pressure, which may eventually cause an explosion, if not properly controlled. We also studied Gay-Lussac's law. Gay-Lussac discovered an important principle about reacting gases. He found that gases react in simple whole number ratios by volume, provided that temperature and pressure remain constant. A common real-life example of this law can be seen when using cooking gas, also known as LPG. During combustion, the gas reacts with oxygen in the air, and both gases combine in fixed volume ratios. This is what allows the gas to burn efficiently and consistently during cooking. Our lesson objectives for today is to explain Avogadro's law. Avogadro's law. Avogadro, an Italian scientist, proposed that equal volumes of all gases, at the same temperature and pressure, contain the same number of molecules. This idea is known today as Avogadro's law. Avogadro's law helps us understand Gay-Lussac's law. It tells us that when gases react, they do so in simple whole number ratios. These ratios represent not just volumes, but also the number of molecules involved in the reaction. Example 1. Formation of water vapor. Let us consider the formation of steam. 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to produce 2 molecules of water vapor. This means the ratio is 2:1:2. This supports Avogadro's law because equal volumes contain equal numbers of molecules. Example 2. Formation of hydrogen chloride. In this example, 1 molecule of hydrogen reacts with 1 molecule of chlorine. This produces 2 molecules of hydrogen chloride gas. Again, the ratio is 1:1:2. This also agrees with Avogadro's law. Let's look at the mole concept. The mole is a unit used to measure the amount of a substance. 1 mole of any substance contains 6.02 times 10 raised to the power of 23 particles. This number is called the Avogadro number. Molar volume of gases. At standard temperature and pressure, 1 mole of any gas occupies a volume of 22.4 cubic decimeters. Remember, learning is a journey, not a destination. Now, let's look at some example calculations. A. Calculate the volume occupied by 2.5 moles of oxygen gas at standard temperature and pressure STP. B. Calculate the volume occupied by 25.5 grams of ammonia gas at standard temperature and pressure. Given, molar mass of ammonia equals 17 grams per mole. Solution. A. Volume of 2.5 moles of oxygen at standard temperature and pressure. At STP, 1 mole of any gas occupies 22.4 cubic decimeters. So, the volume is equal to 2.5 multiplied by 22.4. That gives us 56.0 cubic decimeters. B. Volume of 25.5 grams of ammonia, NH3. First, we find the molar mass of ammonia. Nitrogen is 14, and hydrogen is 1 times 3. So, the molar mass is 17 grams per mole. Next, we calculate the number of moles. Number of moles is equal to 25.5 divided by 17. This gives 1.5 moles. Now, we calculate the volume. Volume is equal to 1.5 multiplied by 22.4. That gives us 33.6 cubic decimeters. Real-life examples of Avogadro's law. Think about something you've probably seen before. Pumping a car tire automobile. When you use a pump to add air into a tire, what is really happening? You are pushing more air molecules into the tire. As more air molecules enter, the tire begins to expand and become firm. This shows us an important idea. The more gas particles you add, the greater the volume of the gas, provided the temperature and pressure remain constant. So, in simple terms for you to remember, increase in the amount of gas leads to an increase in volume. Congratulations on completing this lesson. You should be proud of yourself. Let's take a few quick questions to refresh our memory on what we've learned so far. In today's lesson, we explained Avogadro's law, which states that equal volumes of gases, at the same temperature and pressure, contain the same number of molecules. We trust the lesson was helpful and easy to understand. In our next class, we'll continue with Gas Laws Part 4. Thank you.